Hello everyone and welcome to this video. In this data scenario, we're diving into high-dimensional data analysis. Our journey will take us through importing datasets, normalizing data, clustering with k-means, and visualizing with scatterplot matrices and parallel coordinate plots. We'll also touch on data reduction techniques. Let's get started. First, we need to set up our environment by importing the necessary libraries. Let's go ahead and import our essential libraries. We have pandas for data manipulation, scikit-learn for clustering and preprocessing, and matplotlib and seaborn for visualization. These are our go-to tools for this analysis. Now, let's load our dataset and take a peek at its structure. This will give us a sense of what we're working with. Let me show you how you can load the dataset using pandas. We'll read the CSV file and display the first few rows to understand its structure. Our dataset includes various metrics for countries or regions, such as GDP per capita and social support. Nordic countries often rank high, reflecting strong social systems and life satisfaction. Let's get an overview of our data. We'll check the data types and summarize the dataset to understand its distribution and characteristics. So what we are doing here is checking the data types of each column. This helps us understand the structure of our dataset. Our dataset has 7 columns. Country or region is categorical while the rest are numerical. This setup is perfect for analyzing socioeconomic indicators. Let's go ahead and get a statistical summary of our data. This will provide insights into the mean, min, max, and other key statistics. We have 156 entries for each variable. The statistics show a wide range, especially in GDP per capita, which varies significantly across countries. To ensure all features contribute equally, we'll normalize the data. This process scales the data to a range between 0 and 1. So let's normalize our data using min-max scaling. This technique scales each feature to a given range, making them comparable. Our dataset is now normalized. The features are scaled between 0 and 1, allowing for a direct comparison across countries. Let's revisit the statistical summary to see the effect of normalization. All variables should now be within the 0 to 1 range. With normalization, all variables are between 0 and 1. Social support has the highest mean, while perceptions of corruption have the lowest. Next, we'll apply k-means clustering to group our data into clusters. This will help us identify patterns and similarities. Let's use k-means clustering to segment our data into 3 clusters. This method groups similar data points together based on their features. The k-means algorithm has grouped our data into 3 clusters. The first few countries fall into cluster 0, indicating shared characteristics. A scatterplot matrix will help us visualize relationships between variables and spot patterns or outliers. Here's how we can create a scatterplot matrix using seaborn. This visualization shows pairwise relationships between our variables. Let's generate the scatterplot matrix to explore the relationships between our features. The scatterplot matrix reveals pairwise relationships between factors like social support and life expectancy. We can see distinct clustering patterns, especially in these areas. Now let's use a parallel coordinate plot to visualize our multidimensional data and observe the clustering results. Let's create a parallel coordinate plot. This plot allows us to visualize multidimensional data and see how each feature contributes to the clusters. Let's generate the parallel coordinate plot to observe the clustering patterns across multiple features. The parallel coordinates plot shows relationships among features categorized by clusters. Let's take a random sample of our data. This helps us manage large datasets by focusing on a subset. Let's visualize the sample data with a scatterplot matrix to see if the patterns hold. Let's generate a scatterplot matrix for our sample data to check if the observed patterns are consistent. The scatterplot matrix of the sample data shows strong correlations, especially between GDP per capita and life expectancy for class 2. Now, we'll apply PCA projection to visualize our data in a reduced dimensional space. Let's use PCA to reduce our data to 2 dimensions. This technique captures the most significant variance in the data. The first 5 rows of our dataset have been transformed into a 2-dimensional space using PCA, capturing the most significant variance. Let's visualize the projected data to see how the clusters appear in this reduced space. Let's create a scatter plot of the PCA projected data. This will show us how the clusters are distributed in the reduced dimensional space. The scatter plot shows the happiness index projected into 2 dimensions. We can see 3 distinct classes, each with its own distribution pattern. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.